Good morning, students. Today we are going to learn about required quality, achieving required quality, how to achieve good quality for software product. So the quality product will be achieved or obtained through a systematic planning and development. Systematic planning and development. If the software company or software top level management follows certain assessment tools, certain measurements, then only they can achieve quality. So in any case, in engineering activity or in any productivity, the quality obtained through continuous observation, continuous monitoring and testing. These three are very, very important. What I am saying, repeat once again: continuous observation, continuous monitoring, continuous testing, and assessment. These are very, very important to achieve good quality product. So, in this class, we are going to discuss about the quality factors, both conventional process and modern iterative process. Conventional software methodology done at early stages. That means around 1980s, during 1970 to 80s. In that period, the software company which followed this principle, conventional software development methods. After 2000 onwards, nowadays, most software companies they are following modern practices, modern development methods. In this slide, you are going to learn both conventional process and modern process with the quality driver. First, quality driver: requirements misunderstanding. Requirements are understand and they are going to uh, misplaced in conventional process, discovered late. In conventional process it is going to identified late, but whereas in modern process resolved early. If any requirements misplaced or misunderstand, that can be resolved quickly in the modern approach. In case of conventional, it will be identified very late. That is first one. Second, development risk. During development of the project, if any risk identified, that is rectified very, very late. Unknown until late. That will be identified at the end. That's why already we discussed about in first unit waterfall model. In waterfall model, all the problems, all the risks are going to be identified at the end. So whatever risk identified at the end, if you want to rectify them, it will take more time. Again, you have to come back first. So cost and schedules are exceeded. That's why it is very risk model. In case of modern, understood and resolved early. All development risks are going to be identified very early. Commercial components. Commercial components not at all available in the conventional method. Mostly unavailable because in those days every function, every program they have to develop, they have to write. That's why it is called 100% customized. All projects are going to be built themselves. Even a small piece of code not at all available from the outside of this organization. They have to scratch and they have to write each and every part of the program their own. That's why it is called 100% customized. In case of modern process, still a quality driver, but trade-offs must resolve early in the life cycle. Commercial components are available so that you can use that code or that tool directly in the software product. Change management, late in the life cycle and malignant. So that means during middle of the project, the any modification or management activity to be changed, that is very difficult in the conventional, but in case of modern practice it is possible. Change management means any management activity means all of a sudden you want to change cost or schedule or any requirement. If you want to change, that is very difficult in case of conventional process, but in modern practice it is possible. Then design errors, all design errors are discovered late in case of conventional, there in modern it is easy. Automation, mostly error prone manual procedures. Most of the mistakes done are identified through manual procedures, but in case of modern process it is identified very easily because of all artifacts are available, mostly automated. Resource adequate, unpredictable, but in case of modern it is predictable. Resources, all resources that you can't predict. Schedules, over constrained. Schedules means cost, time, and personal staff. And another important thing is development schedules are going to over constraint. Over constraint means they may exceed, but in case of modern practice, tunable to quality, performance, and technology. All schedules within the budgets. Target performance, paper-based analysis, and separate simulation. In case of modern, executed prototypes, early performance feedback, quantitative understanding. Here, everything is possible through OOAD principles. OOAD already, if you want to understand the system, we have use case, sequence diagram, deployment diagram, etc. These tools will allows you to understand the problem quickly. Software process rigor, document based, but in case of modern, managed, measured, and tool supported. So now you have observed the difference between conventional and modern. Conventional means old system, old methodology, which were followed by the software companies during 1970s, 80s. So in that time, most of the projects entered into immature process. 90% of the projects may not completed within the schedule because of these problems. In case of modern practice, so 70% is commercial components, 30% is customization. 30% is customization means they will do the programming only 30%, remaining 70% the modules and the components available from the internet or from third party trade off business easily. We will avail them and we will reuse the commercial components in our projects, so that definitely, as noted here, schedules and design errors, automation, everything done within the schedule. Okay, right. See, key practices to improve overall software quality, including the following: focus on driving requirements. All uh, requirements you should analyze very easily. Using metrics and indicators should be followed. Provided integrated life cycle environments. Visual modeling and higher level languages are to be used. Early continuous insight into performance using through demonstration based evaluations are done easily, so that the quality will be achieved by following these things. Then conventional development process stressed early sizing, timing, and estimates computer program resources utilization. which includes project inception, initial design review, midlife cycle design review, integration and testing. So project is to be inception means you should understand all the requirements, and design should be done early. Design review means whatever the design done by the architecture, that we have to review it. That is done by specialized teams. Specialized team is going to review the design. Through the with the help of review, any error or risk is followed, that can be identified. Any risk will appear in further, that can be identified by the review. Integration and testing, finally everything is over, that all modules are integrated and tested. If any software organization will follow all these principles, definitely the software project comes with a quality one. Okay, good. So what you have learned in the 5 classes, we'll go through one by one. See, in this, we are in the second unit, part A. Okay, second unit, part A, improving software economics. How many tools are there? Economic parameters, software economics parameters are 5. There are 5 basic parameters of the software that affect the cost of the software. Cost will vary from all these 5. One, size, process, personnel, environments and quality. In the entire second unit, part A, we have to focus on the 5 economics. Okay, just look on this: size, process, personnel, environments and quality. Briefly I will say, size means you have to reduce the software size as possible as. If you reduce the software size, cost will also decrease. Then process, if you improve the process, automatic cost will come down. Personnel, development staff. Development staff means the people, those who are going to involve in the development of the software project are known as personnel. Environments, already just previous class we discussed about environments, the working environment, the tools and different artifacts are required to build the software product. And quality is at most important. If you produce quality software product to the client, the client definitely they feel very happy, and automatically you will get good software projects from the same client from our other clients. Quality is going to achieve through continuous monitoring and testing and assessment. So the 5 are very very essential. These are known as software economics. And I advise you, please remember this table. If you manage this table, the 5 software economics and trends, you can remember the entire second unit, part A. You will get one question from these 5. Sometimes they will ask you all 5, or sometimes they are asking 2 to 1 size. Explain how to reduce software size, how to improve process. Sometimes they will ask you personal and environment, like that. So if you manage, if you remember the 5 software economics, you will answer one question sure in the university end examination. And the trends means shortcut we have to remember. So software economics and followed by trends, how to achieve a particular software economics. And the aim of software economics already told you in the previous slide also. There are 5 basic parameters of the software that affect cost of the software. Cost of the software depends upon 5 major economics: size, process, personnel, environments and quality. Okay, good. So last one small topic will be there in the second unit, part A, that is peer inspections or a pragmatic view, that we will discuss in the next class, right?